All right, you guys, we're going to continue our discussion about exponential functions. So we have this theorem that says for an exponential function, f of x equals c a to the x, where a is greater than 0, a cannot equal 1, and c cannot equal 0. If x is any real number, then f of x plus 1 over f of x equals a, or f of x plus 1 equals a f of x. Okay. Now what this means. So if you guys remember a while back, we wanted to know if they gave us a data set, we wanted to know how could we classify it as a function. And before, we only learned about linear functions. What this theorem allows us to do is take any data set and classify it as if it were an exponential function. Okay, so let me break down what the theorem is saying. So the theorem is saying that if you have a data set and if the ratio of consecutive outputs is constant. Okay, so if you have a data set and the ratio of consecutive outputs is constant, you have been given an exponential function. Okay, so let's kind of break down those terms. Okay, so ratio means to divide, right? And consecutive means one after another. Okay, outputs are the values that come out of your function, and that means that they stay constant. They stay the same. Okay, so it says that if you divide terms that come one after another, then their output should stay the same. Okay, so an example of that would be if our exponential function was f of x equals 2 to the x power. And if I calculated f of 1, f of 2, f of 3, and f of 4, and I found those values, f of 1 would be 2 to the first, which would be 2, 2 to the second, 4, 2 to the third, 8, 2 to the fourth, 16. So it says that my ratio of consecutive outputs should be constant. Okay, so I'm going to say 4 divided by 2. Okay, I'm going to say 8 divided by 4. And I'm going to say 16 divided by 8. Well, 4 divided by 2 is 2. 8 divided by 4 is 2. And 16 divided by 8 is 2. This value all the way down is constant. It stayed the same, which proves that yes, I did have an exponential function. Okay. Now, if you guys remember when we looked at linear functions, that is different. So when we talked about linear functions, we had f of x equals mx plus b. Okay, this is for linear functions. And if we wanted to know if the data we've been given was a linear function, we were looking to see if the average rate of change was constant. Okay, which another way of thinking about it is a slope constant. Okay, so now we're going to be able to tell if we've been given a data set whether or not that data can be represented by an exponential function or a linear function or neither. Okay, so let's take a look at these examples. Okay, so in these data sets, okay, I want you guys to be able to tell me if the data set can be represented by a linear function, an exponential function, or neither. So let's look at A first. Okay, so for each data set, they have calculated the average rate of change, and they have calculated the ratio of consecutive outputs. Okay, so if the average rate of change is constant, that means that the function you've been given can be represented by a linear function. If the ratio of consecutive outputs is constant, that means that your function can be represented by an exponential function. Okay, so let's look. So remember, to calculate the average rate of change, if you guys don't remember average rate of change, that formula was f of b minus f of a all over b minus a. So that means that we're going to take f of b minus f of a over b minus a, which is how they've gotten these calculations. The change in y over the change in x, okay? If you want to think about it as your slope formula, same deal. So they've gone through and they've calculated the slope, the average rate of change, all the way down, okay? And you'll see that they get the same value, -3, -3, -3, okay? Now, they've done the same thing with the ratio of consecutive outputs. They've calculated it all the way down for this data set. So consecutive outputs means they would have 2 over 5, -1 over 2, -4 over -1, -7 over -4, all the way down. And you'll see that these terms, they're not constant, okay? So based on the one that is constant, we'll tell you what type of function you can use to represent this data. So in this case, this data can be represented by a linear function, okay? All right, let's look at the second example. All right, so once again, they've calculated the average rate of change for the data set all the way down from point to point, and they've also calculated the ratio of consecutive outputs. So remember, if the average rate of change is constant, then you can use a linear function. If the ratio of consecutive outputs is constant, you can use an exponential function, okay? All right, so as we are looking at these terms down all the way down, we will see that our exponential function, our ratio of consecutive outputs is constant, which means we can use an exponential function. Okay, and let's look at our last example. Okay, so once again, they've calculated all the way down the average rate of change and the ratio of consecutive outputs, and you'll notice this time that neither of these is constant. Okay, so don't feel like when you're classifying these that you have to be either linear or you have to be exponential. Sometimes sometimes your data set won't fit into either one of those categories. So for this one, we would put neither. It's neither linear or exponential. Okay, I hope this makes sense.